Problem 3 tells us that $18,753 is invested at an interest rate of 6.9% per year, compounded continuously, and we are asked to answer these questions. So let's start here in Part A. In Part A, we are asked to find the exponential function that describes the amount in the account after t years. Now, I'll write this formula here. Now, this is going to be the amount depends on time, and it's equal to this. P naught, now it's because it's continuous compounding, I'm going to write this, e to the kt. You know, the regular formula, if you're compounding, say, not continuously, the formula would be this. A of t equals P naught times 1 plus r over n to the nt, where n is the number of compoundings per year. But when n goes to infinity, the number of compoundings becomes continuous, then we get this part right here goes to e. So for us, we're going to have A of t is equal to, now the original amount is 18,753 e to the k, 0.069 t. So there is part A, that is our function. Now in part B, here's B, what we want to do is, what is the balance after 1 year, 2 years, 5 years? Let's just do this let's do it for 1 year first of all. So here's what I'll have. What is the amount after 1 year? So it's going to be 18,753 e to the 0.069 times 1. So on our calculator, put in 18,753. Then you press the second key. Then you press the ln key. When you press ln, you get, we want second, so you're going to get e to the x. Then what happens is that your cursor comes up, right? So we're going to get e, then your cursor comes up here, and you're going to type in 0.0691 times. Now I'm going to go ahead and put a 1 here, just to show you where everything's at. So let's type that into our calculators. And I got that the amount after 1 year is 20,092 point, it's money, so I'm going to round off to 2 places. So after 1 year, here's the amount, 20,092 and 64 cents. Now, after, what's the next one? 2 years. Okay, so what is A of 2? Now, all I'm going to do to get A of 2 is, I want to compute this. I want 18,753 e to the 0.069 times 2. But the only thing that's different between this one and the one we just did is instead of a 1, right, instead of a 1, we have a 2. So on your calculator, you can bring back this by doing this, all right? Type second, all right, so press second. And then down at the very bottom right, you'll see an enter key. So you press enter. It's the very bottom right. Press enter. And right above enter, it says entry. So you press second enter. It brings back the last thing that you entered. And the last thing we entered was this, 18,753 e to the 0.069. And then we had a times 1, all right? But now what you're going to do is, you see your blinking cursor, use your left arrow key, and left arrow once or twice, but get that cursor right on the 1. So the cursor should be on the 1, and then just type in 2. It'll replace the 1 with a 2, and then press enter, and I got 21,527, say 99, if I round it off. All right, so we start with 18,753. After 1 year, it's gone up to 20,092. After 2 years, we're now at 21,527. And the next one is 5 years. Now, I'm not going to do the 5 years. I'm just going to replace now the 2 with a 5. Now in part C, we're asked, what is the doubling time? Well, here's the formula for the doubling time. It's always this. It's the natural log of 2 for doubling over K, and K is the rate of change, or in our case, the interest rate. So T is equal to ln2 over 0.069. So I'm going to press the ln key. I get a parentheses, put in a 2, close the parentheses right above the 9, divide 0.069. And I got T is about 10.05. I'll round it off. So the doubling time is just about 10 years. So whatever, just look at your account at any particular time, look at the amount in your account. In about 10 years, it will double. Whatever that amount you're looking at, in 10 years, it will double.